Hi everyone, I'm Sharmila from Can Do Teach, and in this video we're going to be looking at negative and fractional indices. So in the last video, we talked about index laws, but we mainly thought about indices as being positive integers. So we thought about things like x cubed, which is x multiplied by itself 3 times. So we have a very intuitive way of understanding what positive integers mean. But in the last video, we saw that we could extend this to understanding x to the power of 0. So even though we can't really say x to the power of 0 is x times itself 0 times, we were able to figure out that x to the power of 0 has to be 1. So now we're going to do the same kind of thing for negative and fractional indices. So making sense of what something like x to the power of negative 2 would mean, or x to the power of 1/2. Alrighty? So, starting with negative indices. So, just like with 0, we can't really say x times itself negative 2 times, right? That doesn't make sense. But if we use our index laws, we can actually figure out a different way of writing it that we can make sense of. So, if we look at x to the power of negative 2, we can remember that the division law ends up subtracting the indices. So we can say that x to the minus 2 is the same as x to the 0 minus 2, right? And so if that's x to the 0 minus 2, we can rewrite that the division way. So that's the same as x to the power of 0 divided by x to the power of 2. And we know that x to the power of 0 is 1. So that's simply 1 over x to the power of 2. Okay? So that tells us that a negative power represents a power on the denominator, so a positive power on the bottom of the fraction. Okay, so in general, we can write that as x to the negative n equals 1 over x to the n. And if you follow through this logic, you can see why this is true. Alrighty? So this extends to even when we have a negative power on the bottom of a fraction. So let's say we had 1 over x to the power of negative 3, right? So we can say that, okay, this looks like this form, so I can rewrite that without the fraction just by changing the power to a negative. So I say negative whatever the old power was. And we know that negative 3 is the same as positive 3. So that's just x cubed. So what we realize is by making the power negative or changing the sign of the power, we're moving the number from the top of the fraction to the bottom of the fraction, or from the bottom of the fraction to the top of the fraction. So in practice, let's say we had something like x squared y, x over x to the negative 4 y squared. Alright, so we can simplify this by saying, okay, if I bring this to the top, it will become x to the 4. And if I bring this to the top, it will become y to the negative 2. And now I can go through and just add the powers. So 2 and 4 is 6, and 1 and negative 2 is negative 1. So I can write x to the 6 y to the negative 1, or I can change that back to the positive index form, which is x to the 6 y to the 1, so just y. Alright, so that's how we can use negative indices to simplify expressions. So now let's go on to understanding fractional powers. So this time none of our index laws really help because we don't have any index laws that divide the power. But we can try to make sense of what this is by calling it something else. So let's say y equals x to the 1/2, all right? And now what I can notice is if I square both sides, that will get rid of my fractional index. Squared, squared, because I know that 1/2 times 2 equals 1. So this becomes y squared equals x to the 1, so just x. And now if I think about solving, so making y the subject, what I would ordinarily do is take the square root, right? So y is equal to the square root of x. So what this should show you is that y, what we call this thing, is actually the same as the square root of x, right? Because both of these things squared just go back to being x, okay? So that actually shows us that the square root notation can be described as an index. And so we can actually apply all of our index laws to surds as well. So in general, I can actually say that x to the power of 1 over anything, n, is equal to the nth root of x, right? So that's what we mean by fractional indices, where the fraction is 1 over something. It's just that root of x. But not every fraction is 1 over another number. Sometimes we have fractions that are, say, 3 over 2. Right? So how would we make sense of something like x to the power of 3 over 2? Well, this time we can use our index laws because we know that powers of powers multiply. So we can split this fraction into x to the power of 3 times half. So because 3 times 1/2 is 3 halves, or 3 over 2, we can rewrite it this way, which means that if we interpret the power of a half as a square root, this means square root of x cubed. All right? So in general, we can rewrite this as x to the power of m to the power of 1/nth, which means the nth root of x to the power of m. Make sense? So while we can't make intuitive sense of what negative and fractional indices represent, we can still use them and therefore apply all of our index laws to them. So to summarize, a negative power just flips the side of the fraction that we're on. So it makes x to the power of negative n become 1 over x to the n, or it can make 1 over x to the negative n, x to the positive n. Right? If we have a fractional index where the numerator of the fraction is 1, well, it just becomes the nth root of x. So whatever this number is on the bottom becomes that root of x. So if we've just got x to the 1/2, that's a square root. If we've got, say, x to the 1/5, that will be the 5th root. All right? And finally, if we have a general fraction, so some number over another number, then this top number becomes the power of x, and the bottom number becomes the nth root of x. So for example, x to the power of 7/12 would be the 12th root of x to the power of 7. And that's it. So hopefully that helps you make sense of negative and fractional indices. If you have any questions, please feel free to ask them in the comments below. Otherwise, you can always find one-to-one help at candoteach.com. Thanks for watching, and I'll see you next time. Bye for now.